So once we have these expressions, we're then, like, we can't do stoichiometry, right? That's the whole point here. So once we have the expressions, we can then put in the numbers and get our answers, like the same kind of answers we would have got with our stoichiometry. How much product would we get or whatever. So I call this my plug and play, okay? So after you've made your expression, you can then just take the numbers from the equilibrium and put them in and get an answer. This will give you the value of the equilibrium constant. So what is my percentage? It's kind of like saying, is this a 1% forming or a 99% forming reaction like we did before in outcome A? And so I have to write my expression. So products over reactants, where this is to the power of 4 because this is the power of 4. This is a homogeneous mixture. All 4 things are present. And so I'm going to include all of them in my expression. So I write my expression. And then it gives me values at equilibrium. At equilibrium, I have all 4 things present. And this is how much I have of all of them. And so I can plug those numbers into the appropriate spot, tappity tap on my calculator, and I get an answer. Now what this answer tells me is this value is super big, right? Super big. Big, by big I mean greater than 1. So this is like much greater than 1. In order for that number to be greater than 1, then this ratio, this quotient, this fraction, has to be big on the top and small on the bottom. Like, for example, 20 over 3 would be bigger than 1, whereas 3 over 20 would not be bigger than 1. So if it's small at the top, right? So this value, because it's greater than 1, tells me I have my top value is big and my bottom value is small, which means that these are a lot of this, and this is just a little bit of this. Which means if I have a lot of oxygen, then I have a lot of oxygen forming and just a little bit of that forming. So this is more like a 98% reaction, not quite 100 because it exists in equilibrium, but definitely not a 1% reaction where most of it is still in my reactants, right? A lot of product form here, a lot of product form here, and I can tell that by that K value. Okay, let's go over here. So here I have a different kind of reaction. Again, I have a homogeneous mixture, and so I'm including them all in my expression. This, it tells me it's an exothermic reaction, but that doesn't matter because, like, we're not in unit 1 right now, right? So although it's exothermic, thanks very much, but don't care. And it gives me the K value. And the question says, if this is the equilibrium constant, and I know I have this concentration of equilibrium, and I know I have this concentration of equilibrium, what is the concentration of chlorine at equilibrium? So I write my expression, products over reactants, and I plug in the values. This is how much I have, this is how much I have, this is my unknown, and I know my K value is 1.9, my equilibrium constant. And so, like rearranging through some algebra, I end up with the concentration of chlorine must be 0.813 moles per liter at equilibrium. So at equilibrium, I have all 3 things present, of which that many moles per liter is the chlorine. The next question says, okay, what's the Kc for my reverse reaction for this thing? So my 1.90 tells me that I have more products than reactants because it's greater than 1. And so my Kc over my forward over my is 1 over the Kc reverse will be 1 over the K of the forward reaction. So 1 over 1.9. So my value is 0.526 for my reverse. So if I'm going this way, I have a number that's less than 1. So I'm not actually making very many products, right? I'm keeping the reactants. And that arrow still then makes sense. I have more of my PCl5 than I do the other stuff. Okay. That is the plug and play aspect of my K expressions. So you can write a K expression and then you can plug and play some values and you can either get the equilibrium constant or you can get some concentrations at equilibrium. And the equilibrium constant can tell you a little bit about whether that reaction favors the forward or the reverse in terms of my arrow sizes and percentages.